Okay, systems of equations. There are many applications involved with these type of problems. You know, again, sometimes in algebra it's a little far-fetched, like who would really do that? Sometimes it's a bit more complex as well, though. So to find this middle ground, right, we develop these kind of more basic problems to get the idea across that sometimes we do have more than one equation that we're trying to find a solution in which it needs to meet all the criteria. So I wrote down the basics of these, but I'll go ahead and read the actual problem. So the first one, it says, word for word, one evening, 1,500 concert tickets were sold for the Fairmont Summer Jazz Festival. Tickets cost $25 for a covered pavilion seat and $15 for a lawn seat. Total receipts were $28,500. How many of each type of ticket were sold? All right, so I took down the bulk of the information, right? 1,500 tickets total, $25 for one seat, $15 for the other. The total sales were that. How many of each? So on one hand, you're like, well, why didn't they just keep better track when they're selling it? Right, yeah, exactly. I mean, I agree, but for the purpose of this problem in this video, it is what it is. They didn't know how many of each, so that's our job to figure it out. All right, one thing to point out. The more complex, the more numbers and variables they kind of throw in here, the more confusing it looks. Often start with the question. Okay, define your variables. How many of each ticket were sold? Well, there were two types of ticket, right? The pavilion seats and the lawn seats. So I'm going to be boring and use an X and a Y throughout this video. But you could definitely use the P, pavilion, L, lawn, whatever variable you want. X is going to be the number of pavilion tickets sold. Okay. Y is going to be the number of lawn seats sold. So the question is how many of each. I'm going to start by just defining my variables like that because overall some of these that you might get lost of how to start it. If you start there, it helps to write these equations. So now look at the information we have. 1,500 tickets were sold. So how would I write that? Well, I know some pavilions and some lawns were sold, right? And that's, in this case, the only two types of tickets. And together, there were 1,500 of them sold. So simply add them up. To make an equation for the sales, well, think of, let's say 10 pavilion seats were sold. Then you would simply take 10 times 25, right? And then 100 lawn seats, so I'd do 15 times 100. Well, the thing is, I don't know how many of each, but the point is, we were multiplying. We had 25 multiplied by however many pavilion seats, and then 15 multiplied by however many lawn seats. The total yielded $28,500. Now I have a system of equations. All right, I almost always will do elimination, so this is a good example, I guess, to do substitution. Switch colors here, because I can easily solve for X or Y. It doesn't matter which one you choose. Okay, I'll go ahead and solve for Y. So I could yield Y equals 1,500 minus X. And I'm going to take that and I'm going to substitute it in here. So using equation 2, right, I would have 25x plus 15 multiplied by Y, which is 1,500 minus X, equals 28,000, 500. Okay, 25x plus 15 times 1,500. Oh, I should know that, but I don't. 15 times 15. 225, that's what I thought. 225 with 2 zeros minus 15x equals 28,500. Okay, combine like terms right here and here. I'm going to go ahead and subtract this to the other side as well. I'm doing multiple steps. You could pause and rewind it to follow along and check it out on your own. But we have 10x equals 6,000. So divide by 10, x is 600. So remember, what does that mean? X, I'm asking how many tickets of each. Don't just leave it as like, oh, x equals 600. Like what is x? 600 pavilion tickets were sold. Okay, and because x plus y equals 1500, we could just do that in our head, right? That leaves 900. Since 1500 tickets were sold, 600 pavilion tickets and 900 lawn seats. And preferably, like, actually write this up, you know, in a sentence, but to save a little bit of time in the video, I don't want to make it too long. I'm going to leave it at that. Okay, we know how many of each ticket were sold. All right. The next question is an investment type. Again, word for word really quick. Charles inherited $15,000 and invested it in 2 municipal bonds that pay 4% and 5% simple interest. The annual interest is $690. Find the amount invested at each rate. Okay, so how much is invested in each? Well, we could just, again, let x be the amount, the money invested at the 4%, right, that rate, and y will be how much we put in, or they put in, at the 5%. So one question, it would be like, well, why don't they just invest it all in the 5%, right? It makes more money. And there are many variables when it comes to investments and interest. Perhaps it's riskier. Perhaps one pays out, you know, the 4%, maybe you only have to leave it in 1 year and take your money out, where the 5% you have to leave it for 5 years or so, you know, to get the better rate. I don't know. That's just the question. We won't get into the quality or logistics of it, but that's what's going on. So you're investing money in 2 different accounts, right? 2 different bonds. So if you put this much in one and this much in the other, and you put 15,000 total, then just like the other one, I know if I add the 2, I arrive there. Okay, simple interest, we, you know, maybe could get this more complex with a different interest, but simple interest simply is you take your percent, multiply it by however much money was invested, and that will give you your interest. So 4%, I'm going to change it to 0.04 multiplied by x, because I don't know how much was put in there, right? That's my x, plus 5%, 0.05y, and I will yield $690 for the year. Okay, that's how our simple interest looks. So now we have a system of equations. Okay, I'm going to first clear decimals because I don't prefer to work with them. We have 2 decimals here, 2 decimals here. So therefore, if I multiply everything by 100, which is equivalent to just moving the decimal place to the right twice for everything, we no longer have decimals to worry about. On that note, I'm kind of double dipping here 2 steps at once. I can see the equation 2 would be this, right? And equation 1, I'm going to use elimination. Let's multiply it by -4 and cancel an x. Okay, I'm going to take equation 1, multiply all this stuff by -4. That way when I combine these 2, I can see right away, right, the x's would cancel. 4 times 15 is 60, so negative 60,000. All right, so this is the new equation 1, the new equation 2. If you need to pause for a second and kind of review that, it'll work. I'm going to move on. When we combine these, as I already canceled these x's, right? That was the point of that. Negative 4 plus 5y is just 1y. And negative 60 plus 69 is 9,000. Y is 9,000. We're already done, right? Y is 9,000. Therefore, if 15,000 was combined total, x is 6,000. That would make 15,000. In all of these, I'm avoiding the check. Kind of make sure your answer makes sense. These seem reasonable, right? Nothing is crazy. But I would recommend checking them as you get used to it. So, how much is invested in each? Well, $6,000, I'm just going to put 6K, is invested in the 4% account, while 9,000 is invested in the 5% account. Awesome. One more example here. Again, I'll go ahead and read it. This is there's quite a bit going on here, but some of it is irrelevant. So a 1-cup serving of spaghetti with meatballs contains 260 calories and 32 grams of carbohydrates. A 1-cup serving of chopped iceberg lettuce contains 5 calories and 1 gram of carbohydrates. They give a source, it doesn't matter. How many servings of each would be required to obtain 400 calories and 50 grams of carbs? Alrighty, so anybody in nutrition or going for that degree, right, maybe this is of interest to you. I mean, really, carb and calorie counting we all should do it. I'm bad, but moving on. Okay, how many servings of each, right? Again, always read the question. How many servings of each? That's going to be my variable. If that's what I don't know, that's my variable. So x will be the servings of spaghetti. Y will be the servings of lettuce. Reading through this too, I'm like, call me crazy, but lettuce needs ranch. And then, hey, you're giving me spaghetti and lettuce with ranch. I'm mixing it together. Spaghetti salad. Sorry, side tangent. Moving on. Okay. X is the number of servings of spaghetti. Y is the servings of lettuce. I want to get 400 calories. Well, I don't know how many servings of spaghetti, right? I just noticed my colors, they were so consistent till now. Oh well. So how many servings of lettuce? I don't know, but 260 calories in each serving, right? So multiplied by, let's say you had 2 servings. 260 times 2, 520. 3 servings, right? So forth. Plus, now I'm looking at calories here because I know the total calories, for spaghetti is 260, lettuce is 5, but total I want 400. So that's the other thing with these often is like, also try to create your 2 equations. I know I have calories and carbs. Those are my 2 equations I'm trying to create. So 260 multiplied by x for the spaghetti plus 5 multiplied by the y, however many servings of lettuce, right, will give me 400. Now let's do the carbs. 32 grams per serving for spaghetti and just 1 for the lettuce, and I want 50 total. So this one, maybe they played around with it a bit to make sure it actually could work. I don't know, but that's what's going on. All right, sometimes with elimination, I'm going to show this little trick that I do. Save a little bit of room. I'll often, all right, I could cancel these y's quite easy if I multiplied by -5. Rather than rewriting both of these, I'll often just do like, all right, this becomes -5y, this is -250, this is -160x, and I'm going to take this equation 1 and this equation 2 and combine them. Right, so I just changed this equation 2 into the line below. So now I'm ignoring that and doing this. Okay, I'm using those two. So 260 minus 160 is 100x. 400 minus 250 is 150. Once I divide, I'll get one. Excuse me. I'll get 1.5. Okay, normally in math, actually, when we divide, this is important to say, 150 over 100, we would divide and we'd get 3 over 2 simplified, right? But in this question, and most word problems, decimals do make more sense. How many servings of spaghetti did you eat? I ate 3 half servings, right? That's kind of weird. So we say 1.5 servings. X is the servings of spaghetti. I ate 1.5 servings of spaghetti. Okay. Let's finish this up. Equation 2, we know x is 1.5. I'm going to use equation 2. It's a little easier. 32 times 1.5. Okay, can't write. Plus y equals 50. So this is 48 plus y equals 50. Y equals 2. So what does that mean? Then we have, I'm going to change to blue, 1.5 servings of spaghetti and meatballs, and 2 servings of lettuce would yield, right, the results they're looking for, 400 calories and 50 grams of carbs.